Vimal. Vimal, you can give the answer on adsorption theories. Baby Kartika.
Yes, ma'am.
Baby Kartika.
Ma'am,
If no one is responding, then I will start the class.
ma'am, adsorption theories are linear adsorption isotherm,
Yeah, proceed.
a Friendlich adsorption isotherm, a non-linear adsorption isotherm, ma'am.
Okay.
Beck theory.
Okay. This only we have discussed.
Yes, ma'am.
Johnson and Vimal, can you answer regarding adsorption theories? Thank you, Baby Kartika.
Thank you, ma'am.
Next class, you must answer you both, okay? Vimal and Johnson. Already I have asked Junai. He has also not answered till now. So in the next class, when I ask for the answers, I expect
Yes,
from
ma'am.
these people.
Good
Then
morning.
John, good morning. Give answer on the last class discussion regarding adsorption theories.
Adsorption theory, ma'am.
Yes. What are the adsorption theories we discussed? Name the adsorption theories. Baby Kartika said no.
Yes, ma'am.
Name the thing.
Linear absorption isotherm, ma'am.
Hmm.
Non-linear absorption isotherm, ma'am. Freenan absorption isotherm, ma'am.
Freundlich.
Yes, ma'am. Beck theory, ma'am.
Okay. Among which, what are the theories applicable for solid and liquids, and which theory is applicable for gas? What are the theories for solid molecules, adsorption, and what are the theories applicable for gaseous molecules, adsorption? Vimal, can you answer? Anybody else? Okay, thank you, Johnson and Baby Kartika. We'll start the discussion on remaining
Thank you,
parts.
ma'am.
Remaining parts of theories, adsorption and partition theories behind column chromatographic analysis. In the previous class, we have started discussing about column chromatography and planar chromatography. The first part of chromatography, we have enoughly made the discussions on planar chromatography. What are the techniques we have discussed? Paper and TLC. In paper, a single paper partition chromatography we have discussed. In TLC, TLC, HPTLC, and PTLC we were discussed. And now we have moved to column chromatography. In column chromatography, before moving on to the individual techniques, we are now learning about adsorption theories, means theories behind principles and the theories behind column chromatography, that is basics. If we learn this well only, we can move into different column chromatographic techniques. And we have discussed the history of column chromatography. It was developed in 1903 by Russian botanist Michael Sweat, and he separated calcium carbonate columns using calcium carbonate columns, plant pigments he has separated firstly, from which all other column chromatographic techniques were being developed. And definition for column chromatography we have discussed. It is also separation and isolation method to get a single chemical compound from a mixture. That is the overall idea about column chromatography. Then coming to principles and theories, it follows 5 different principles: adsorption, partition, ion exchange, gel filtration, and size exclusion principles are followed. Adsorption means adsorption taking place at surface of the stationary phase. So all the principle are followed between stationary phase and mobile phase for the separation. Either we can follow adsorption between stationary and mobile phase, or partition, that is partition coefficient, distribution of solute between two phases, that is stationary phase or mobile phase. Then ion exchange, ions, cations and anions exchange will take place between two phases, that is stationary phase and mobile phase. Then gel filtration, using gel will be filtering out the molecules according to its molecular size. So gel filtration and size exclusion will be following mostly same principle. And then one more is affinity chromatography. This affinity, gel filtration, size exclusion, or follows same principle only. Okay, that is separating the molecules according to its particle size, molecular size. If smaller molecules, they will be separated later. If it is big molecules, it will be eluted from the column fast. That concept, separation will be taking place for mainly polymers. Macromolecules, this type of techniques will be preferred, gel filtration and size exclusion. Where other techniques follow specific separation, ionic separation if you want to perform, then we have to go with ion exchange. And apart from this, common principle for all the molecules are adsorption and partition. This is about principles of column chromatography. What is the common two principles we'll be following all through the chromatographic techniques? Adsorption and partition. Other specific principles are ion exchange, gel filtration, size exclusion, affinity, this all. Okay. So specific means they are specific to, if ion exchange, if you take, it is specific or particular to ionic compounds. Gel filtration and size exclusion, these are particular to macromolecules. So seeing the specific nature of solute, will be preferring different principle of separation. And next we have discussed regarding adsorption theories. What are adsorption and partition overview? Here it is given. What are the adsorption theories? Linear or Henry's adsorption isotherm, Freundlich adsorption isotherm, and non-linear or Langmuir adsorption isotherm, and bed theory. Under partition theories, what we are going to discuss is column efficiency parameters. Partition theories are nothing but column efficiency parameters. They are partition coefficient, retention time, retention volume, capacity factor, selectivity factor, band broadening theories, then resolution. These are most important. Comparing adsorption theories, partition column efficiency during separation or isolation. And this question regarding column efficiency parameters, you will be getting frequently, means asked question you will be getting from column efficiency parameters in university. So learn this column efficiency parameters well. Okay. And what are the adsorption theories we have discussed? Linear, Langmuir and Freundlich adsorption isotherm. Where linear, stationary phase, concentration of solute in stationary phase is directly proportional to the concentration of solute in mobile phase. Q is directly proportional to C. Q here represents concentration of solute in stationary phase. Imagine stationary phase and mobile phase. Stationary phases of column, mobile phases of flowing liquid. Moving liquid, right? And concentration of solute means your sample between two phases. Concentration, how much concentration of solute is present or exist in stationary phase, and how much it is present in mobile phase. Both will be equal or linear. When concentration increased in stationary phase, mobile phase concentration also will be increased. Concentration of solute in mobile phase also will be increased. That is the concept for linear. For Langmuir, it will be non-linear. Either concentration will be exceeded in stationary phase, or it will be exceeded or lowered in mobile phase. Likewise, non-linear adsorption takes place. in Langmuir. That is explained by Langmuir theorem. And Freundlich theorem also says no much change occurs between the concentration of solute in stationary and mobile phase. Slight changes will be there. That is represented with this graph. You can find linear adsorption isotherm, Freundlich, dissolved concentration of adsorb, that is in mobile phase, is slightly increased and it is coming to the linear position. No, but Langmuir, it is highly non-linear. So medium adsorption is Freundlich, where Langmuir is non-linear, it is linear. Okay. And K represents in this equation equilibrium constant between two factors, concentration of solute in stationary phase and concentration of solute in mobile phase. With this two factor, equilibrium constant is K, or it is called as adsorption constant. Since it is coming into the process of adsorption, it may be called as adsorption constant. Okay, so what is Q from the equations of adsorption? Adsorption density or concentration of solute in stationary phase. And C represents what? Dissolved concentration of adsorbate. Dissolved concentration means concentration of solute in mobile phase. Since it is liquid, we are calling the solute that is dissolved in mobile phase. So it is mentioned here as dissolved concentration of adsorbate. Adsorbate is nothing but a sample molecule. Okay. And this is equilibrium constant. Clear, no? About adsorption theories, there are three theories: linear, non-linear, or Langmuir, Freundlich. Linear is defined by Henry, so it is called as Henry's adsorption isotherm. And note down the year in which year the theories are developed. 1906, linear and Freundlich; 1916, non-linear; 1938, Bett theory. So these three theories will be applicable for solid or liquid samples, mostly solids. Solid only will get adsorbed onto the surface molecules, right? So the molecules in solid or liquid phase can be adsorbed, and that principle is explained by these theories. Three theories, where gaseous molecules adsorption is explained by Bett model for multi-layer adsorption, where other theories are explaining mono-layer adsorption, where Bett model or Bett theory represents a multi-layer adsorption. Okay, here you can see the multi-layer adsorption. It is represented for Bett model, and this is the equation 1 by V, P0 by P minus 1, and C minus 1 VMC, P by P0 plus 1 by VMC. Here V represents adsorbed gas quantity. Adsorbed gas quantity, how much total quantity of gas is adsorbed. And P0 represents saturation pressure of adsorbate. Pressure here represents vapor pressure. Adsorbate is gaseous molecule. So vapor pressure of gas, saturation vapor pressure of gas. Okay. Whenever you fill gas, you will be giving some space to occupy its pressure, right? So that is called as saturation pressure. Then P represents equilibrium pressure of adsorbate. Equilibrium pressure. At what stage it is getting equilibrium with the adsorbent, that is equilibrium pressure of adsorbate. Your adsorbent will be of solid medium, where adsorption of gaseous molecule occurs. This is the solid medium, and here are the gaseous molecules getting adsorbed into multi-layers. Okay, monolayer is explained by Langmuir model, multi-layer is explained by Bett model, and Bett model is merely for none of the gas will form monolayer, right? So it may be giving multi-layer adsorption. In that case, Bett model will be properly fitting for the gaseous molecules adsorption. And C is Bett constant. It is equal to exponential of E 1 minus EL divided by RT. E is energy difference. Okay, and E is energy difference of the gaseous molecule adsorption. And here you can see here it is heat of adsorption. Heat of adsorption for the first layer, and heat of vaporization. EL is heat of vaporization. Heat of adsorption and heat of vaporization. That means energy of adsorption only here is mentioned with heat of adsorption. One represents monolayer. One represents monolayer. That is first layer. Here you can see the first layer, and EL is heat of vaporization. How much heat it is getting to vaporize. So these are all the factors, and RT is constant temperature. This one is constant. Only this difference, energy difference is noted. And these are all the parameters substituted here to plot a curve, and it will give slope and intercept from which we can find out how much adsorption has been taken place. This is gaseous molecule adsorption has been taken place, can be monitored. So this is the theory applicable for gaseous molecules adsorption in multi-layer form, that is bed theory. Brenner, Emmett and Teller theory. You can observe the image, and here is the explanation for your equation. Here is the graphical presentation of gaseous molecules adsorption. So clear about adsorption theories, no? What are the theories? There are 4 theories: linear, Freundlich, non-linear and bed theory. Where other 3 theories, first 3 theories are applicable for solid or liquid adsorption, where bed theory is merely applicable for gaseous molecules adsorption. Okay, linear, where concentration is directly proportional to stationary phase and mobile phase, will be in equilibrium. Where Langmuir, it will be non-linear, no linear adsorption takes place. Where in Freundlich, it is of medium linear adsorption taking place in the Freundlich theory, according to Freundlich theory. Then Beck model explains totally about multi-layer adsorption of gaseous molecules. This is explained with the formula mentioned. Next, we'll move on to the important part, that is partition theories or column efficiency parameters. Under partition theories, what are the theories we have seen? Partition coefficient, retention time, retention volume, capacity factor, selectivity factor, band broadening theories, and resolution. Now we'll see the first 5, and the next class we'll see the remaining. Okay, I'll take another 10 minutes. Due to a research meeting, I have come late, okay, principal meeting. So that I couldn't cover, I thought to cover the whole chapter. Today we'll cover with only the 5 points of partition theories. Partition coefficient is nothing but the equilibrium between absorption of sample or a distribution of sample in mobile phase and stationary phase. So both will be equal. That means the distribution of your sample occurs between mobile phase and stationary phase. When it is attaining equilibrium, at what stage it is attaining equilibrium is called as and calculated with partition coefficient. And no 2 samples will be having same partition coefficient. That is taken as the principle for separation. Okay, so that all the components will be having different partition coefficient. It is convenient to separate and identify the molecules. Because no 2 components are having same chemical structure, so they will be having then different properties of distribution between mobile phase and stationary phase liquids, and both will be of immiscible liquids. Stationary phase and mobile phase will be liquid in partition coefficient, both will be of immiscible liquids. In between immiscible liquids, your sample will be distributed, and one point it will get equilibrium between, the distribution gets equilibrium between 2 phases. That is called as K. K is nothing but partition coefficient. So partition coefficient is represented with K, that is equilibrium between distribution of solute in stationary and mobile phase. Okay. Then next point is retention time. The time between sample injection and an analyte peak reaching a detector at the end of the column is termed the retention time. Retention time here you can observe from the point of injection when the analyte reaches the peak maxima is called as retention time. And Tm is migration time. Each analyte in a sample is not the time taken for the mobile phase to pass through the column. Okay, from here only actual separation occurs. Even retention time must be taken from the first peak to actual peak maxima. This is the time between sample injection and actual retention time, not from actually 0 points. In eliminating migration time, you can calculate exact retention time of the sample. That means this peak represents where only your injection sample enters the column, so that it is giving the peak migration time. So the time taken for the mobile phase to pass through the column is called as migration time, and the retention time is the time between sample injection, where even you can take this as sample injection position, and an analyte peak reaching a detector at the end of the column is termed retention time. Or we can say 50% peak maxima during at particular retention time, it reaches peak maxima, or 50% elution takes place in the column. 50% it is coming out from the column, or it reaches 50%, that is represents maximum retention time or maximum elution at 50% level. Okay, that is called as retention time. So time from point of injection to peak maxima. Peak maxima represents 50% elution. Remaining 50% elution takes place from the column. So this is called retention time. It is the qualitative parameter in column chromatographic techniques. What is qualitative parameter in planar chromatographic techniques? It is RF value. Here it is RT value. We can call, and from the textbook, I could find this as TR. TR is nothing but retention time. Even you can write RT, like RF, you can write RT. RT is nothing but retention time. Capital R and small t, T will be in subscript. Okay, you can write like that. So that is called retention time, and it is qualitative parameter. We are not going to consider migration time and other parameters. This retention time, how long the sample takes through the column to elute out 50% elution or to reach peak maxima is called as retention time. And what is retention volume? The volume of mobile phase required to elute particular solute from the column. How much volume of mobile phase is required to means elute the particular solute from the column. For this much elution, between the time, if you consider this is 5 minutes time, it has been eluted. So for 5 minutes elution, how much volume of mobile phase is used? And what flow rate it is used, based on which we can calculate retention volume. So retention volume is nothing but retention time into flow rate. It is depending on flow rate of mobile phase. If you send 1 ml for 5 minutes, then it has consumed more amount. If you set 1.1 ml per minute, then it is of less mobile phase for 5 minutes. Likewise, so it is depending on flow rate of the mobile phase. So retention volume is depending on retention time into flow rate, where F is mobile phase flow rate. Okay, it will be given in milliliter per minute. Unit of F is milliliter per minute. Retention time is in minutes. It is in minutes. Maximum we can run the sample for 15 minutes. Ideal retention time is 0 to 8 minutes. Okay. Like ideal RF value 0.1 to 0.9, right, below 1. Likewise, ideal retention time is 2 to 8 minutes. That is called as ideal retention time for any sample. If you develop a retention time for new sample, then ideal retention time will be means 2 to 8 minutes. It is in minutes. Okay, it's about migration time. So next remaining parameters we'll discuss in the next class then. Capacity factors, it will take another 15 minutes to explain, so that I will stop with this now. So in column partition theories, as a column efficiency parameters, we have discussed partition coefficient, retention time, retention volume, among which migration time also is discussed. Okay, there are 4 headings we have discussed. What is partition coefficient? What is retention time? Retention time is, with one word you can remember, it is indicating time taken for 50% elution. 50% elution or to reach peak maxima. Either you can say it is peak maxima, or you can say 50% elution of solute. Okay. So for reaching this maxima, how much time in minutes the solute takes through the column is called as retention time. What is migration time? The how much time the mobile phase is taking to enter into the column. You think that is the column of separation, where for entering into the column from the reservoir to column, how long it is taking mobile phase, that is called migration time. Okay, And what is retention volume? How much volume of mobile phase is used to get a retention time, that is peak maximum or 50% dilution, is called retention volume. It is depending on flow rate of the mobile phase. When flow rate is increased, then volume will be increased. So it is directly proportional and it is multiplied with retention time factor in ml per minute. How much ml is passed in minute? That is called volume of retention time. And this will be given in ml per minute. So minute and minute will be cancelled. So volume will be getting ml. So how much ml of mobile phase is used can be calculated. Retention time unit is in minute into flow rate unit is milliliter per minute. So minute and minute will be cancelled. So volume will be getting milliliter as unit. Okay. What is F? F is flow rate. Flow rate of mobile phase through the column. Okay. And migration time, you know, the time taken for the mobile phase to get into the column for separation. Okay. These are all the three parameters we have discussed now and three theories of partition. Okay. And what is qualitative parameter for column chromatography among this? Retention time, not partition coefficient, not retention volume, not migration time. It is retention time, RT or TR, RT only. Okay, RT is retention time. Unit is in minutes. What is ideal retention time? 2 to 8 minutes. What is the maximum retention time or maximum time we can give for a sample to elute out from the column? 15 minutes. Okay. Okay, thank you all for listening. We'll discuss in the next class tomorrow morning the remaining parameters. These are all the parameters we are going to discuss. Go through. I have uploaded PPT also, right? Go through what are the parameters I have uploaded. We'll discuss tomorrow. Okay, thank you all.
Thank you, ma'am.
Is there any doubt? Okay. Tomorrow, Vimal, you must answer regarding this. Vimal and Junaid. If you are not answering for 2 or more classes after asking, then your attendance will be continuously absent, even if you present also. Thank you.
Thank you, ma'am.
Thank you, ma'am.